Hey guys, Travis Gillespie here. We're looking at unique sequences, and this problem's asking us to find the first five terms of the sequence defined by this generic formula here. It's just a general formula that we use. A sub n is equal to n times n minus 2. This is just a generic formula for this problem specifically. So let's go ahead and actually list out the first five terms. In fact, I'm going to start with a sub n. A sub n is my generic term. It's talking about the nth term. Now the nth term, it's actually right now what we call this subscript. It's called an index, and when I build multiple indexes, I have indices for plural. So index is singular. Just a sub n, it's saying, hey, what is the term that I'm looking at right now? Right now I'm looking at the nth term. It's any term. So let's go ahead and build the others. So I have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 here on bottom. Now I might go and separate this out later, but I'm not too worried about that right now. So using that generic formula here, my indices here are 1, 2, 3, 4, 5, just depends on which one I'm looking at. I can build these now using this generic formula. I want to get rid of that information and actually write the formula in its place. Alright, so writing this out, a sub n is equal to n times n minus 2. Alright, so now I can substitute values into this equation. For a sub 1, it's going to be 1 times 1 minus 2. For a sub 2, it's going to be 2 times 2 minus 2. So notice, whenever I run into the variable n in my equation, I'm just taking the value from the index and substituting it in its spot. So for the first term, I took the value 1 and substituted it in for n. For the second term, or a sub 2 here, I took the 2 and substituted it in for the n. So for a sub 3, 3 is in the index, so I'm going to substitute 3n for n, so 3n minus 2. A sub 4, I'll substitute 4n, so 4 times 4 minus 2. And then finally for 5, I have 5 times 5 minus 2. Alright, from there I'm just going to solve these problems. So I'm going to work inside the parentheses first. So 1 minus 2 will give me a value of negative 1. So now I have 1 times negative 1. 1 times negative 1. 2 minus 2 gives me a value of 0. So now I have 2 times 0. So now for these next ones, I'm going to probably run out of room. Let's go ahead and just slide that down some. And now I'm just going to separate these out. Alright, so for 3 minus 2, I'm left with 1, so now I have 3 times 1. Alright, so 4 minus 2 is 2 times 4. 5 minus 2 is 3. I'll multiply that by 5. Okay, so 1 times negative 1, that will give a value of negative 1. 2 times 0 is 0. 3 times 1, I get 3. 4 times 2, I get 8 here. And 5 times 3, 5 times 3 will give me 15. Now I can actually take all these values and write them in a list, just kind of organize them. So negative 1, 0, 3, 8, fix that 8, and 15. And then I can box this information up here. Cool stuff. So I found the first 5 terms in the sequence. So when working with sequences, what's neat here is that when you have a generic formula, or this generic formula here, although it's a general formula for the sequence, it allows us to generate numbers pretty quick. And it doesn't have to just be numbers in order from 1 through 5. In fact, you can find any number in the sequence. Alright, I'll see you in another video.